Let's take a look at the next definition. Here we're going to connect vector field and line integrals together. Let F be a continuous vector field. So since we have a vector field, we're going to use bolded letter. Let F be a continuous vector field over a smooth curve like C on a smooth curve like C given by function RT. So again, I'm going to use bolded letter R to represent the vector definition of this curve C. And suppose your T is bounded between A and B. So now that you have a vector function, you're interested in knowing how to find the line integral, the integral of this vector function over this smooth curve. The line integral of F over C is defined this way. Line integral F dot, guys, we are using the dot product, dot dr. You have two vectors and you are connecting these two using the dot product over curve C, which actually can be written as the integral A to B F of RT. So you just substitute R into function F dot dr is R prime dt. This guy is also equal to the integral F dot T ds over curve C. So give us an example. You gave me the definition. Suppose I ask you to find the work done by the force field. Remember that when we talked about vector field, we actually introduced some force fields like gravitational field and yes, the magnitude. Yes, that's correct. So we introduced some vector fields as well. Question says, find the work done by the force field, which is given to you as F of X and Y equals to, you have X squared as your X component and negative XY as your Y component in moving a particle. Moving a very small object along the quarter circle, a quarter circle RT. So here you have your vector. Let me just use bolded letter instead of putting a dash on top of it. RT, which is cosine T, comma, sine T, and T, since it's a quarter circle, it means that you are here. You are in the first quadrant. So T is bounded between 0 and pi over 2. Perfect. We have a nice formula. Let us follow that formula. X is defined as cosine and Y is defined as sine. We just need to plug those into the function. The line integral becomes 0 to pi over 2 F of RT. So here I have cosine squared, comma, negative cosine times sine, dot product, guys, dot product, R prime of T r is cosine t, the derivative of r is negative sine t, and the derivative of sine is actually cosine t dt. So remember the dot product. If you have AB dot CD, it is AC plus BD. We're going to multiply the first components, multiply the second components, and add them together. So this guy becomes integral 0 to pi over 2. The multiplication is negative sine t cosine squared t. And here you have negative cosine squared t sine t dt. Well, if you combine these together, here you have negative 2 sine t cosine squared t. We can use u sub negative 2 sine t cosine squared t dt. Use u to be cosine t. Du becomes negative sine t dt. So this guy becomes 2/3 cosine to the third t between 0 and pi over 2. So obviously here you have 0 minus 2/3. So what's the meaning of this negative sign here? Why my force work done by this force field is negative 2/3?